Hello, and welcome to the Download Community Tech Talks by HPCC Systems. This is our second episode, and we're glad that you're able to join us today. As we get started, I want to share some basic housekeeping. First off, please share this with others that you know. Please tweet as the presentations are going on, and just let others know that you're here with us. We're using the hashtag HPCC Systems Tech Talks. Also, ask questions. We're going to answer as many questions as we possibly can following each speaker, so we welcome your questions. Also, throughout the presentations, we'll be doing some polls. They'll show up at the bottom of your screen, and if for some reason you can't see them, please exit the full screen mode or refresh your screen. Also, we welcome your feedback. At the end of this session, please rate us before you leave and visit our blog for more information. You'll see that there's an attachment where you can download the presentation, but all of this information will be on our blog after the presentation. And as you go through this, if you think that you have a story that you might want to share with the community or some information that would be valuable to others, please let us know. techtalks@hpcsystems.com. At this point, I'm going to hand it over to Flavio Villanustre.
Hello, everyone, and it's a pleasure to be here again on our second issue of our Tech Talk, the Download, HPCC Systems Call. This is, I think it's a great opportunity to listen to very good content. We have one of our most well-known community experts, Fujio Turner, who is going to be speaking about some of the things that he has done around IoT and HPCC. Fujio has been in the community for several years now. He is now a Couchbase solutions architect for mobile. And he has traditionally specialized in high-speed data platforms and has done several things throughout his career around technology, and he was a LAMP stack developer. And he has even some interesting innovations around things like 3D JSON, and if you don't know what that is, you should ask Fujio, and virtual reality and big data. So that's our first talk, and I think it's a great talk. I heard Fujio talking before in many other areas, and he's a great speaker. And after that one, we have Jacob Pellock, who works for LexisNexis as a senior director, but he is also heavily technical and hands-on. And he has been working with HPCC for several years now and has done very interesting things in the analytical area. So that's a great presentation too. After him, for those that have an interest in machine learning, we have Roger Dev, who works in our machine learning team. He's a senior architect for LexisNexis 2, and he has been working in machine learning and AI for several years now. And in the HPCC area in particular, he has been working on improving and enhancing some of the algorithms that we have in that area. And last but not least, we have Richard Taylor. He's our chief trainer, and he has been involved with HPCC for now almost 2 decades. He has developed the vast majority of our online massive open courses for HPCC. And he will be covering some of the training that we have around KEL and other also quite useful tips on some of the things that are coming throughout our training pipeline for HPCC. And now, without more preamble, I want to give the floor to Fujio for his talk. Fujio, it's all yours.
Thank you so much, Flavio, for that great introduction. I've been using HPC, what, 3 years now, right, as my main data platform. When I first saw HPCC, right, I saw a great product, and the best part is, as far as I was concerned, was it was open source. So my time and energy when I put into it, I knew that I would eventually be able to get it back out, partly because there was no potential vendor lock-in. And that's the same thing with Couchbase. I started using Couchbase 2010, 2011 timeframe, and I knew it was going to be a big platform for big businesses, so I supported Couchbase at one of their biggest customers for about 3 years, and I just left about a year ago to work specifically at Couchbase, specifically at the mobile and IoT platform that they have. And now I'm sort of happy to say I'm still continuing to work to merge the two together, or get them to at least talk to each other, and to be able to give them this presentation. So let's start it off with a poll, quick poll if we could. This is a question I ask a lot, and I get a lot of response as far as how people's businesses are changing. I guess the question is, do you see mobile data being a bigger part of your business? This is sort of a new trend, or actually it started around 2010, right, as when the first iPhones or devices came out, right? We changing from Nokia and Blackberries to sort of more of an interactive device. We're seeing, some people are seeing, based on their specific businesses, a larger shift from the web to the mobile device. So if you could answer that question really quickly, that'd be great. So why should we care about mobile and IoT, right? Well, we should care about mobile because that's where our primary user information is, right? You get your emails, your maps, messages. There's tons of apps that you probably have on your phone to interact with. The other reason, it's your primary social hub, right? You're interacting with nearly all your peers and maybe your friends and family through that device. And then currently it's your secondary purchasing hub, right? So brick and mortar stores you still need to go buy groceries, right? But pretty much everything else other than sort of a lot of the basic things that you need day to day can be bought and purchased through your mobile device, right? So the problems that it's seeing is like syncing data, just being able to get data back and forth through the device in a timely manner. Speed of the data, right? So not all networks are created equal, right? And so that helps that's another problem that's built into sort of syncing. And inaccurate and stale data. So that has to do with the above. Plus, a lot of our backend systems aren't really designed to have real-time information exchange, right? So in the IoT space, right, people just want better predictor systems behaviors, right? So the idea is, for example, GE is one of our customers. What they do is they say we can guarantee performance on your assets by collecting a large amount of data and determining when the failure points are, right? So both on the micro and the macro and the micro scale, we also see IoTs important for safety, right? Being able to collect all that information. And just pure aggregating doesn't do much. They want to be able to know that leaky faucet of that specific bat in a plant that's a very micro level. So automation, right? They want machines to automate themselves or machines to watch other machines. And another thing is companies want to have a customer view, like a complete customer view, right? So what are they doing interacting with me, not just interacting with me directly, but through the secondary means, and also now through these other IoT devices. So the problems that they have is sort of the classic problems, right? Collection, transport, storage, and analyzing data. So if you really look, right, these problems are universally shared between both of these sort of things because they're sort of different sides of the same coin, right? IoT still have syncing, data inaccuracy, right? Mobile has collection, transport, storage, and analysis problems. So in many ways, they're sort of, I believe they're the same thing. So what are people asking me, right? So people are usually asking me this. My data scattered, right? I have my data for my customers are in over 20 different databases, and it's just hard for me to just be able to find out what's going on. So they want to potentially consolidate data. Personalization and customization. So when they interact with people, they want to be able to give them that sort of customized feel, approach, that specific app or the way they're interacting with that company is sort of super unique to them, right? So that's where classification and clustering becomes extremely important. And guess what? HPCC systems, machine learning is perfect for that. And the third thing I get is my data needs to do more for me. So what they're really saying is, I want easy analytics, right? I want to be able to iterate through my data quickly and easily. And lastly, I would say they want to move faster, and they want to move with more agility with their data. So the two platforms I think that are pretty great at that are Couchbase and HPCC systems. So Couchbase, right? What is it? Well, as far as the mobile solution is, it's a full end-to-end solution. So we have an embedded NoSQL database, right? It's embedded in the device. It ships with your application. It does full CRUD and query functionality. The Sync Gateway, it's sort of the cornerstone of this whole operation. So all data goes in and out through there, and it does all your REST, syncing, streaming, batch, and even event APIs. And the thing that I've been working on for almost like 5-6 years, right? Couchbase Server, right? It's your clustered NoSQL database that's known for a high scale, availability, and high performance. Primarily does operations key value lookups, and you can also do SQL queries against the database. So in the beginning, syncing a user's database is really easy, right? We do a POC when the mobile device on the left and the database in the data center on the right are offline from each other. They just journal the changes, and when they have connectivity, they just sync up, right? That's real easy. So the problem becomes when you have something that looks like this, when you have millions of devices out there, and everybody's information on their phone is critically important. And apparently every couple of years they upgrade their phone, right? So then so you constantly, and then when they buy their new phone, they want the same information that's inside their old phone. So it makes perfect sense. I would want that same thing too. So how do we go about doing this, right? So most people in the beginning, right, they say, well, I'll do some read side filtering. So the idea is that when a specific user comes in, I'll sort of identify the specific pieces of information that the user needs and then deliver that information. But the problem with read side filtering is it's just too slow, right? So because you can only execute so many queries per second, and then potentially then to increase that, you say, well, I will do batches and then I put them inside of a cache. So now it makes the problem potentially worse. So you have more throughput, but then your accuracy as far as usability of the data becomes more stale, right? So the way that Couchbase sort of really handles the problem is instead of partitioning data at the time of read, we partition data at the time of write. So as items and data goes in through the Sync Gateway, it gets tagged or puts into site-specific channels. So before we see now we have a Bob user, and so we can have a Bob channel, right? So all those things that are associated with Bob go inside his channel. So it makes it super easy to be able to deliver that information, right? Because we know exactly what pieces of information that user should be seeing. So now when the user pulls data from Sync Gateway because he's offline and he wants to check up, he gets a specific sequential stream. So all data inside the database has an incremental sequence number associated with it. So in this example, this yellow user here, between 20 and 17, there's 18 and 19. He doesn't have access to it. Maybe they're gone, or maybe somebody else has. That belongs to somebody else's channel. So now that we sort of have the concept of a private channel, so yellow can have a channel, blue can have a channel, right? And then we can even have, everybody has it. So there's a public channel, which everybody has access. Or maybe I want to restrict that channel to maybe a small group of users. I can do that. And I can even share channels. So why would I want to share channels? Well, maybe I have a grocery list where I want to share it with my spouse. Or maybe another use case would be, I have worker A calls in sick, right? So I need to redirect the work from worker A to worker B. So maybe the manager would just share worker A channels for that day, right? So now that yellow user has access to blue, yellow, and red channel, his stream would look like this, right? And this is great, but what ends up happening is not all pieces of information, first of all, are the same size and or have a certain amount of same priority, right? So could I filter information? And the answer is yes. So you can have an open TCP stream connection where you can have a continuous stream So the idea is that as soon as any change comes in and it gets synced down, I can get that immediately. And then you can schedule or just sort of batch your pulls like every 2 minutes or every 5 minutes. Or you can even create another pull off of a specific channel or channels, right, for every 15 minutes when they're on Wi-Fi, because the large may be image. So you might want to be respectful for the user. Right? So next question I usually get is, how do I integrate mobile into my systems, right? So I say it's relatively pretty easy. Remember, we have the concept of users and we have the concept of channels. What you can have is sort of a master user or a user who has access to most of the channels, and he would just make a relatively simple call to a sync gateway, whether it be a streaming call or a batching call, to be able to access the feed that that specific user has. You would have a sort of an app, Node.js, Java, C# app, that would consume that information and then query your backend, right? So like here on the right, legacy systems that you have, right, problem tables, we give it to you in JSON, right? So it's in a denormalized format. So the next question is, how do I put it inside of there? You still need business logic to put inside of your infrastructure, but you can be able to do that, right? Relatively pretty easy. So this is great, but what does that have to do with HPCC, right? Well, actually, it's relatively pretty easy. Right, that consumer could be Roxy, and it could just make a ECL, a small little work unit, to go do a REST call to pull information from Sync Gateway. And now Roxy doesn't like to have long-running jobs, right? So you potentially don't want to do it necessarily streaming or continuous, but you can do it every second, half second, every 2 minutes, every 5 minutes, right? It depends on your specific need, right? So another question is, well, this is great, but what if I want to consume different pieces of information with different streams, right? Well, you can have multiple work units, right? So you can have one that only listens to specific channels, right? And a channel doesn't necessarily need to be related to a specific user. It can be, but you can have, so a document can be tagged to both the Bob channel and maybe the California channel. So so the idea is maybe that specific app wants to listen to all the people in California for whatever reason. You can do that too. So this is great, but one of the questions that I get a lot of is, how do I simplify my organization? So the idea of consolidation once again. So what we can do is you can publish information into Sync Gateway, which stores it inside Couchbase server, right? And Couchbase server is an in-memory clustered database. So to be able to do more throughput, all you need is more Sync Gateway. So you can horizontally scale both the sort of the web tier layer and both the database layer. So when you insert data inside Couchbase, you get a piece of JSON. It gets version. So every update, there's an incremental version plus a hash. So you know it's unique. And so now anybody inside your organization, whether it be an app or a mobile device, can be able to consume that information, right? And they can pull based off whatever their specific frequency needs that they can have. So another thing is we can even have a sort of a master, or you can chain the sync gateways together for data locality or for filtering. So this is critically important for a lot of the customers who have specific data sovereignty and compliancy and privacy concerns, right? So the idea is that, hey, regulations have changed, so XYZ pieces of information for German users cannot leave the data center, they can't leave the country. So for us, it's actually relatively pretty easy. You can just maybe change some of the documents that are associated with those people, or stop or change the modification of the pusher, right? Because what you can do is you can have multiple pushers based push on different channels, right? So, or another reason why is data locality. So we have a pretty large airlines that is centrally located in Chicago. If you're pretty smart, you can sort of figure out what that is. And so the idea is that I have sort of a central repository in the center of the country, and the east and west, I don't want to duplicate my data. So the idea is that maybe the people in the west don't need to learn about Channel Z, because Channel Z is about a flight from Paris to New York, right? But Channel A might be a flight from LA to New York. So those people at both ends want to know about Channel A of that flight. So you have the ability to do that. So most people eventually sort of create this infrastructure to be able to pull data and push, right? So that's IoT too, right? So there, you can also push data up to you. There's nothing to prevent you from doing that. So to be able to do something like this, so they build a sort of an infrastructure, and they have different apps publishing on different channels, right? And on each one of these, they have specific single sign-on methods where they can. So there's the idea that any user can go over inside of these endpoints and just use one method to sign in. And that there's a per user, there's a sort of assignment of channels and access and roles to be able to consume the specific pieces of information they have access to. So the next usually question I get after this is, well, if you guys can do this, do I need Kafka or TIBCO? And a lot of our customers are finding out, well, actually don't. Partly because once they go in, it gets to that sort of the simplified consolidation requirement that a lot of companies are having. So we also can do SQL, right? So how do you do SQL on a denormalized object, right? So this is how you can find this specific piece of information, right? We're SQL 92 compliant, and we're not truly anti-compliant because we don't have a concept of tables, right? We have a concept of like a namespace called a bucket or database, right? So this is how you do this type of query. So the next question I usually get is, I don't want to do a full table scan, right, or a full database scan. So you have the ability to create indexes, right? So you can create an index, and you can create a covered index, and you can have it 100% in memory, right? Or you can have the index be primarily in memory, but then also be able to be an actual physical file on disk, so you can maybe read this large index. And we can even put where predicates inside of that. So you can partition your data maybe on this one by type, right? Or maybe by city or state or however that you want to partition your index. So one of the first things that I asked is, okay, well, this is great, but how normally I would have this, maybe this is a profile store for TED, and I would have friends in a different table. So how do I sort of, and now I put them all in the same sort of data structure, how do I find friends? Because normally I would do a foreign key relationship with a join. So this is how you do it, right? Friends is an array, X is an iterator through that array. So then you say any X in friends that satisfies X dot name equals Bob, you will get. And the good benefit behind this is also you can create an index off of a nested array object, right, to be able to find that information for you. So this is my last slide. So one of the things that I usually get is, what I would say is Couchbase is really a story of consolidation, right? So a lot of times I have a lot of customers say, well, I have MongoDB or Cassandra, and we do have people who put Couchbase on top of Cassandra, who say, well, I already have these infrastructures. And I says, yeah, you can run some caching on top of these things, or you can just run on Couchbase. And I says, well, I also need to be able to do BI and business intelligence off of that, and also I need to index it and query it. And I says, yeah, but you probably could also use Couchbase. And then I usually get, well, you know, mobile is becoming very important to my business. Well, and then I says, yeah, well, you can build out your whole infrastructure from scratch and come up with some type of messaging queuing system to broker information back and forth, and then build your own database on multiple devices, but you could just use us. And they say, well, I need Kafka and TIBCO to move information throughout my whole organization. I says, well, I guess you can, but you could just use Couchbase server and C gateway to do that too. But in not just a master-slave, but in a master-master format. And then they say, well, I need full-text search, right? So currently we're going to be offering full-text searches in Developer Preview 2. And then we just announced in our last conference that we're offering analytics. So those people who are looking for sort of deeper parallelized analytics, we can do that too. So that's why what I would finally say is, right, Couchbase really is a story of consolidation. So usually when I ask if you compare the Couchbase here on the left versus the column here on the right, which one do you think is cheaper to operate? And most people say Couchbase. And then I say, if you compare both the left and the right, which one do you think has more uptime and is easier to manage? most people usually say Couchbase. So a lot of times, people, when they're making their next generation or they're moving to mobile, they're considering Couchbase as a major part of their infrastructure. So the last poll that I have is, do you see more data coming from mobile or IoT devices? I'm very curious about this, partly because I always want to be able to talk to see where the trend of the industry is going, right? So if you could, that'd be great if you can answer this question for me.
All right, Fujio, thank you so much. While everyone is answering that poll question, I'm going to go ahead and look at the first one. So the question was, do you see mobile data being a bigger part of your business? And overwhelmingly, it looks like 80% of our audience believes that it is becoming a bigger part of our business. So that's fantastic news. Okay. And votes are just now starting to come in from our new poll, so we'll get back to that in just a second. So quick reminder, if you have questions for Fujio, go ahead and enter them, and we will address those in just a second. Okay, so before we start asking Fujio's questions, we've had a few really good questions come in. So the first one, how do I get a copy of the presentation? We will be uploading it after the event today, so you can look back there, or go to the HPCC Systems blog, so hpccsystems.com/blog, and you'll see a blog post come up later today with all the information about today's event, a link back to today's event, as well as the attachment. The presentation will be available for you. And another question that came through is, where can I get hands-on learning options about HPCC Systems platform? And that's an awesome question, but we're going to hold it for Richard because he is our chief trainer, and he can give us all that information when he's done. So a quick look at our poll. Let's see. Looks like we've got a lot of questions coming in. A lot of answers. Okay, so do you see more data coming from mobile or IoT? It looks like we've got 60% from mobile and 40% from IoT, so definitely quite a bit on both areas, so that's fantastic. All right, Fuji, are you ready for your questions?
Sure, I know there's a lot of them. I don't want to keep suck up everybody's time, so let's just go over a few of them. And there's some great ones, so just email me those, and I'll just respond back to those.
All right, perfect. So the first one, Fujio, for you is, how does Couchbase integrate with Solar and Roxy?
So the good news is I've been talking to some of the engineering members of HPCC, and actually we're going to be integrating one of the main methods to get data inside of Couchbase. So it could be used as a key value store inside of like on HPCC systems through through a piece of ECL code, right? Right. Remember, I was saying in the beginning, Couchbase can do key value operations, so that's one part of integration. And the second part is that other part where I showed you. I have a small piece of ECL code that I sort of have that I'm working on just to be able to pull data off, and it's relatively pretty small, but I just want to sort of work on it a little better before I give it out to the rest of the community here.
Okay. Another question, Fujio. Can this setup be used for streaming processing, for example, to handle triggers to be executed when certain events happen?
Yes. So that is one of the main, if you sort of look at the system, you can use it also as an enterprise service bus system, right, to where you can consume information and then do specific actions on there. Right, so you can use it for a whole bunch of myriad of things to interact with the users or a group of users, or use it for other pieces of information. So we have one group, some academic group, that's using it to collect data from different sensors throughout the California for tremor information, and be able to collect and aggregate that, and they have a live stream that wants to consume off of that and make decisions in within 20 seconds if there's going to be a big earthquake. So you can do that.
Okay, and we've got time for, I think, one more question for Fujio here. Can Couchbase be used as a Delta base from Roxy? And if so, is there a public ECL bundle for it?
Yes, you can, right? So there's a few people on the LexisNexis side sort of making that already. It's a little more involved question, but I'd be happy to answer that maybe a little later. I just don't want to sort of take all the time up for these questions. Right?
Certainly. All right, Fujio, thank you so much. So if people are interested in learning more, I will have the questions out on the blog. I'll send them off to Fujio, and as soon as I get them back, I'll add them to our blog. And the other thing is that Fujio's agreed to come back to our Tech Talk podcast, which is a separate series that we have where we have more in-depth conversations with folks. So if you have additional questions for Fujio, go ahead and submit them, and we'll see if we can address them during that podcast in the next few weeks. All right. Fujio, thank you so much for your time today. And next up, we have Jacob Pellick. So, Jacob, over to you.
Welcome. Hello, my name is Jacob Pellick. I work for LexisNexis Risk Solutions, where I manage technology efforts within our business intelligence organization. What I'd like to talk to you about today is what you do after you have your HPCC cluster configured and you have some ECL code written. I'd like to talk about how you transition into an automated operational system and what tools we have utilized in our own ecosystem within the team that I work at within LexisNexis to help us meet these goals. So I'd like to go ahead and start off with a poll. What I'd like to do selfishly is get a little bit of a sense of where the audience is in their HPCC deployment. Are you just in an evaluation stage? Maybe you are only becoming familiar with the technology. Are you maybe this call is your first exposure to the technology? Are you setting up or configuring an environment? So are you actually at a stage where you download the installation and you are configuring your own HPCC cluster? Are you actively developing code, or have you actually picked up enough ECL to be dangerous and you're actually making some progress in that respect? Or are you actively in production where your code has been deployed and you're actively getting value out of your investment in HPCC? So I'd like to give you a little bit more background on the team that I work at here at LexisNexis to give you a little bit of context. I work, as I mentioned before, inside a business intelligence organization. We manage a central HPCC-based data warehouse for LexisNexis Risk. Our data warehouse is on a regular daily basis receiving hundreds of files from dozens of different sources on a daily basis. The files are then loaded onto an HPCC cluster and merged with the existing data sets. It's really what you would refer to as a data lake type of architecture where the source data is all loaded in its raw form, merged into the data lake or our HPCC cluster. And it's integrated and enhanced. And then also the data structures are built to support analytic use cases. Analytic use cases can be executed directly against the data lake for some of your more advanced users, but then we also build curated data outputs that are delivered into what we would refer to as data ponds for other systems that integrate with our ecosystem and for the direct analytics of our users. Our technologies that we use inside of our platform are, well, of course, HPCC and ECL for all our different data warehouse, data integration, transformation, distribution. We also utilize Git, which is a distributed source code repository. I'm probably not going to be able to do a lot of explanation on Git within this call. It kind of deserves its own. But the way that we utilize it is that we have a authoritative repository where our users fork and build their own ECL code and push it to their own forks of the authoritative repository. And then they would submit merge requests to the authoritative repository. And once their merge request would get merged into a release branch, we automatically would deploy the code that's merged into that release branch onto our landing zone where all our jobs are executed. Just to give a little bit of insight, a landing zone would be a file server, which is traditionally used for files to be dropped onto the landing zone, where then they can be picked up and loaded on the HPCC system, or the other way around, where we're despraying data off of the HPCC system onto a landing zone to be disseminated into other environments. In our environment, we utilize Python for scripting. It's really kind of a glue that we leverage to help integrate with other systems. So we're using that for pushing and pulling files across systems. In our environment, we have a number of cloud systems that we integrate with that have the Python APIs. So we'll use Python to be able to integrate with those systems. And then we also use it for moving around files, archiving files, and kicking off jobs. Also very core into our HPCC integration is the HPCC client tools. So we would utilize these simple command lines that come with HPCC, and they are very core to the automation activities inside of our environment. Now I'm going to be focusing on two of the HPCC client tools that are core to automate the submission of jobs on the HPCC cluster. The first of which is ECLCC, which is a compiler, and the second of which is ECL, which is a command line interface that, amongst other things, can do job submission. So drilling in a little bit more on the ECLCC, it has multiple options that you can pass into it, and you will pass in a query file or an ECL file that you would want to have compiled. ECL, one of the advantages of the language is its modular nature. So one of the things that you'll do as you become more advanced in the ECL programming language is start leveraging reusable objects in the forms of modules and functions and other attributes that you can use to build complex data transformation activities. So very often the code that you're compiling is going to be much more than just the file that you're passing into the compiler, but also you'll need to reference a path of all the different other ECL files that you're importing in order to be able to make that happen. So in bold here is the I option. So that is where you would specify the path to your ECL imports. In our environment, that would be where we have cloned our Git repository into our landing zone. So that's where all our code is kept. Also, the O option is used to specify the name of your output file. In our environment, what we utilize is this E option, which outputs the output of the compiler into an archive, an XML archive file. If you were to take a look at one of these XML archive files, what you would see is the ECL code, not only the ECL code that you passed into the compiler, but all of the dependencies that go into making up that job. So that all gets structured into a single XML document. And here is an example. So in this case, you're calling the ECL compiler ECLCC. The -I option is specifying the ECL imports, which in this case would be the directory for where our Git repository is located. The -E option is that we want to specify an XML archive for the output. The -O is used to indicate the name for that XML archive. And the final parameter is my job, which is the code that I'd like to be able to pass into the compiler and all of its required dependencies. So moving on to once we have generated that XML archive, the next step is to be able to execute that job. The ECL command line, amongst many other things, can be used to run an archive and submit it to the HPCC cluster. So we'll be focusing on the run command that you can pass into the ECL. And of the number of different ways that you can run a job, we're going to be focusing on the archive option. You can also specify, work units, ECL files, and compiled objects to be able to submit for run. In the case of an ECL file, what it will actually do is the earlier step that I described with ECLCC, where you would pass in the file and point into the libraries. You could actually do this all within the ECL command, and what it would do is it would compile your file, and it would then pipe the output of the archive file into the ECL Run command. So that's another way that you could possibly implement the same thing, but only with one command call. There's a number of different options you need to specify in order to be able to execute your job against a cluster, one of which is the cluster name. An HPCC environment can have multiple clusters on it. The name of the job is very beneficial to be able to then be able to log into ECL Watch and be able to look at all the different jobs, search for jobs, and help categorize all the different work units on your cluster. You can also specify a wait time period in milliseconds for how long you'll wait. Your command line will wait until the job is complete. You'll need to specify the server that you're executing against, and then the username and password that your job will be running under. So here's an example, simple. This compiler fit onto one line. This fits onto two lines. So we're passing our previously compiled archive into the run command. The cluster we're executing is Thor. We're specifying a my Thor job is the name for our job. Then we're specifying the username, password, the server location, a wait time, in this case of 10 seconds, and then the my archive file, which was generated from the previous compiler command. So that's really basically all you would need to know in order to be able to automate the submission of your jobs against an HPCC cluster. I'm going to talk about some additional. I'm going to also mention some additional commands that are available in the client tools. One of which is ECL Plus. This is another command line tool that has a lot of overlap with the ECL command line. We would recommend using ECL instead of ECL Plus, as this is legacy and eventually is likely to be deprecated. The DFU Plus is a command line tool for file system operations, so this can be used to spray and despray files on and off of your HPCC cluster. In our environment, we actually leverage the standard file system library that you have available to you in ECL, and it's really just a design decision to be able to implement that type of code inside of our ECL. We feel is a little bit cleaner than if we implement it inside of our scripting layer. Okay, so hopefully now you're thinking that that was very simple, and I'm ready to automate all of my HPCC jobs. And also I wanted to give a shameless plug that there's going to be a part 2 where one of my colleagues on March 30th will continue this conversation, and she will be describing how to migrate from a MySQL code repository to Git within a production HPCC ecosystem.
All right, Jacob, thank you so much. Really quickly, I'm going to take a quick look back at the poll. So the question is, what stage are you in with your HPCC systems deployment? It looks like 18% are in early evaluation, 13% are just setting up or configuring their environment, 27% are developing code, and we've got 40% that are actively in production. So we really have a pretty good mix of people across the development cycle, so that's fantastic. All right. Jacob, are you ready for a few questions?
Yes, sure. Mm-hmm.
All right, great. How do you integrate Git with your IDE, Integrated Development Environment? Do you use ECL IDE or Eclipse?
I personally use the ECL, I use the Eclipse IDE, but then a number of different team members on our team use the ECL IDE. It's actually probably more widely used. So the answer to that is kind of twofold. Depends on what you're using. I use just the standard Git add-on for Eclipse, and that works fine. Also within the ECL IDE, we have a couple different options that people use. There's the Tortoise plugin that works with Windows Explorer that is very commonly used on our team. And then also a lot of people that use both the ECL IDE and Eclipse leverage the command line utilities to integrate with Git.
All right, thank you. And do you use embed Python? If so, do you have some open source ECL bundles available?
We do use embed Python. I mentioned before that a lot of the scripting that we do on our landing zone utilizes Python, but so it's a skill set that our team utilizes. And then there are a number of different cases where we have utilized Python also within our ECL through the embed capability. We've used that for some different string types of manipulation that are just very easy to do in Python. In some cases, we've used it to be able to call out to web services utilizing Python. So that is something we've used. I don't have any bundles that are available, but I think that's a really good idea. It's something that we should probably look into if there's any sort of reusable embedded Python uses that we have, being able to expose those through bundles.
Okay, and it looks like we have one last question here. Could I automate my jobs programmatically through an API?
Yes, there is a web-based API. So almost everything that I've done can also be done through a web-based API. The command line is really just kind of a shell around that. So so there's a whole host of functions that are available through the web-based API.
All right, Jacob, thank you for joining us today and presenting this information.
Thank you.
All right, so now we're going to hand it over to Roger.
Hi, I'm Roger Dev, and I work with John Holt in the machine learning group. Today I wanted to talk to you about our linear algebra subsystem. There are two levels of it. One is called BLAS, and that is a open source standardized interface for linear algebra, and parallel block BLAS, which is a proprietary linear algebra system. Now, give a quick introduction here. We wanted to find out if you've had occasion to use linear algebra in your work. It's not something everybody uses. Many people use things that depend on it, but I'm curious to see how many people use linear algebra directly. So, taking a look at the two products, or the two subsystems, BLAS, again, is an industry de facto standard interface for linear algebra operations. It's very mature, has many different implementations, and it's highly optimized for different hardware architectures. As of HPCC 6.2.0, BLAS is part of the STD library, standard library, and you can use it just by importing std.blas. Now, I missed a slide here, and I'm going to go back. No, it's there. Excuse me. So, looking at the next layer, we have parallel block BLAS, and this was originally developed by John Holt, and it provides a BLAS-like interface, but that can scale to huge matrix sizes. John originally developed it as part of the ECL ML library, our beta-level machine learning library. And interesting bit of urban legend here is that John actually had to go back to papers that were written in the 1960s to create this. Back in the 1960s, machines had K memory, kilobytes of memory versus megabytes and gigabytes that we have today. And even to do a moderate-sized matrix operation, you had to figure out a way to break it into pieces and to handle it pieces separately. So the PB Blast will scale to very, very large matrix sizes. And it allows you to balance the workload across a cluster, simultaneously perform independent operations on many matrices in parallel. And this is currently an installable bundle at the top level of the HPCC systems organization on GitHub, so that can be installed and run at any time. So a quick review, linear algebra for our purposes is about matrix operations, being able to do matrix operations like multiplies, solves, factors, etc. On a large scale. So a quick review of matrices for those whose algebra is a little bit rusty. Matrix is made up of rows and columns. We say that this matrix has n rows and m columns, making it an n by m matrix, and in fact it's a 5 by 6 matrix. Each cell of that matrix then has contains a numerical value. Matrices are used in all different types of engineering applications, especially in machine learning, which is why we have built this. It's a foundation to many of the machine learning algorithms. So if we look at a matrix multiplication, in this case I'm multiplying a 20 by 1000 matrix by a 1000 by 1000 matrix to produce a 20 by 1000 matrix. Now, this has several problems in terms of scaling. So in order to do this multiplication, you multiply each cell in the row of the first matrix, which is 1000 cells, by each column, by each cell in the column of the second matrix, and that produces one cell of the resulting matrix. So you can see that this has got some severe scaling issues. One is that the data is not non-localized. You can't break it into pieces and handle those pieces individually on different nodes in your cluster. The other problem is computationally, it scales roughly with the cube of the size of the matrix. So a typical off-the-shelf system can handle matrices of a few million cells, but with PB Blast, we can handle many billions of cells in a matrix. So the question is, how do we parallelize that to run on an HPCC cluster? Well, the first thing we do is break the matrix into blocks. So in this case, we start with a 4,000 by 4,000 matrix, which gives us 16 million cells. So we don't want to try to execute that on a single machine because A, it might take a long time, and B, it will probably run out of memory because the matrix has to be stored in memory in order to access the cells from different rows and columns in order to perform the calculation. It's difficult to stream it. So what do? We break that into perhaps 4 by 4 block partitions, 1 million cells per block. Each block is 1,000 by 1,000, and this is called square partitioning. In another case, we might have a matrix that's 8 million rows with only 4 columns. It's 32 million cells. We can't really break it up into square partitions because if we did, we would only have be able to break it into 4 columns, and we'd have 2 million cells in each column. So instead, we do row partitioning in this case. So we could break it into 250,000 by 1 block partitions, 1 million cells per block. Each block is 250,000 rows by 4 columns, and that would be considered row partitioning. If it was the opposite way, it would be column partitioning. And so PBBLAST handles all of this for you. It calculates the optimal partition sizes, how to split up that matrix, and this is called auto partitioning. So now let's take a look at how we optimize this to run in a cluster. So we take the same example as before, a 4,000 by 4,000 matrix, 16 million cells. We break it into 4 by 4 block partitions. But what happens if we're running this on a 25-node cluster? Now we can use 16 nodes, 1 for each partition, but the rest of the nodes would be sitting idly. So it might be better if we broke it into a 5 by 5 block, 640,000 cells per block, and each block would be 800 by 800. And then we could split that evenly across that 25-node cluster. So this is what PBBLAST will do. It's called workload balancing. And it will attempt to use all of the nodes in the cluster to perform the operation. It can't always use all. Sometimes it's more efficient to run on a few than to try to split up the job too finely. But in general, it will balance across the nodes in your cluster. So let's take a look at how a distributed operation would work. So in matrix multiplication, we're starting with the same example we used earlier. 20 by 100 times a 100 by 100 gives you a 20 by 100. Now this is a small example. I didn't want to try to draw too many cells or to use large numbers here. So in this case, we really wouldn't have to partition because it's small enough to handle on a single node, but add a few zeros to everything, and it becomes a good example. So how does this work? So remember again that you multiply it in order to get this one cell in the destination, the blue cell. You have to multiply all of the columns of the first row of the first matrix with all of the cells in the first column of the second matrix, and then add up the results. So we assign this first cell to one node in the cluster, and we replicate all of the cells from the first two matrices to that same node. Now, we calculated another cell, the yellow one here in this case. We take the second row and the second column and do the same thing. So that gets allocated to a second node. And we do that for every partition in the solution. Notice we're not doing this for every cell. We're doing this on a partition by partition basis. So we're treating the whole partition as if it is a single cell of a matrix. And remember, the partitions are about 1 million cells each. So now we're doing those partition multiplications on these nodes locally. using the BLAS locally on each machine. So this is operation localization. So it allows us to distribute the workload efficiently across the nodes in the cluster and have them all execute in parallel locally without moving data once it is all set up and the partitions are distributed to the right machines. So now you may also want to do many smaller operations. So say you have a bunch of operations that could be run on a 1 or 2 node cluster, but you want to do 1,000 of those operations. So PBBLAST supports a facility called myriad operations, and this allows you to specify, in this case, the first matrices are considered the A matrix, the second is the B, and the third is the result. It allows you to specify a whole bunch of A's, a whole bunch of B's, and receive a whole bunch of results. Now this lets you, rather than using perhaps 1 or 2 nodes at a time if you did these operations independently, this allows you to balance all of those operations, execute them all at the same time across your cluster. So something else you notice if you look into these at any depth is that both BLAST and PBBLAST, which is based on the BLAST interface, handle composite operations. So you won't see the things that you might expect if you haven't used BLAST in the past, like a multiply and a solve and a factor. You'll see composite operations, and the reason for this is that many operations are almost free when you do them in conjunction with other operations. So for example, the generic multiply method allows you to do a alpha and optionally transpose A, multiply it times B with an optional transpose, add in a C matrix so it's scaled by a beta parameter, and so by allowing you to do these commonly used combinations of operations, you get much faster performance than you would if you did the transpose and then multiplied by alpha and then did the multiplication of A and B and then added the scaled C matrix to it. So by combining them, you can get much higher performance, and that's the method that's used by BLAST and PBBLAST. So in summary, BLAST is used for, it's optimized local operations on moderate-sized matrices, while PBBLAST scales to huge matrices, provides efficient utilization of cluster resources, and allows you to do multiple operations in parallel. In general, unless you have some overriding reason, you're going to want to use PBBLAST on the HPC system, HPCC system clusters, because it provides you a singular interface where you can do any size operations and do many operations in parallel. So I'm going to end with another poll. Do you think you may have use for BLAST or PBBLAST in the future? And this one, it may be using it directly, or you may be using it indirectly through machine learning algorithms or other higher-level mechanisms.
All right, thank you, Roger. So while those results come in, we'll take a quick look at our previous poll. So the question was, have you had occasion to use linear algebra in your work? And we have a fairly even distribution there. So 45% have answered yes, and 54% have indicated that they have not. So we'll come back to the current poll in just a few minutes. Let's see. Actually, it looks like results are coming in pretty quickly. So it's also fairly evenly split. So it's approximately 45% are saying yes, 45% are saying indirectly through machine learning, and right now approximately 10% are saying no. But let's keep watching this, keep submitting your votes, and we'll look at that again in just a second. So Roger, here we've got a few questions for you. So the first one is, are there particular optimizations for triangular matrices?
Yes, both BLAST and PBBLAST provide a triangular matrix solver that allows you to solve systems of linear equations that either of the AX equals B form or the XA equals B. And in that case, A would be a triangular matrix.
All right, great. So what are the OS library dependencies to install PBBLAST? Do I just need to install the ECL bundle, or is there anything else that's needed?
Good question. So let's start with the BLAST library. The BLAST library is part of the standard platform library, and one of the reasons for that is because it will automatically bring in the C code for BLAST. It will install it on your platform as part of the platform install. So that's very friendly. You don't have to do any extra work. And then PBBLAST will then just install as a bundle over that. It has a dependency on one other bundle, which is our machine learning core. So you will need the machine learning core bundle as well. But the bundles, if you haven't installed bundles before, the process is very simple and fast. It takes just a couple of minutes to install those.
All right, and it looks like we have one last question, Roger. Is the geometry of the matrix limited in any way for PBBLAST? For example, can a row vector be partitioned across multiple nodes? And what about a column vector?
Yes, it will automatically handle it for all of those cases. In fact, there are optimizations for multiplication of row and column vectors that give you even more efficiency. So yes, it's completely flexible, the shape of your matrices, and it'll try to optimize the partitioning regardless of the shape.
All right, fantastic. So just a real quick look back at your poll, Roger. It looks like we're still evenly split. We got several more answers. So yes is at 47%, indirectly through machine learning at 47%, and only 5% are no now. So excellent results. All right. So Roger, thank you very much for your presentation. And now I'm going to turn things over to Richard Taylor, who's our Chief Trainer for HPCC Systems.
Good morning, everybody. I don't know about you guys, but I've just learned a lot. So I'm hopefully you'll get a little bit out of this one too. Let's start with the first poll question here. Is I'd like to know how aware everybody is of how many different ways we deliver our ECL courses. So if you could answer that question while we go along here, that would be really nice for me. I have a bit of an announcement here that we are renaming some of our ECL courses. We have taken the Introduction to ECL and the Introduction to Thor, and we've combined them into Introduction to ECL Parts 1 and Part 2. The content of the courses hasn't really changed, but the names, I think, are better describing exactly what it's all about, because the Introduction to Thor class really wasn't about Thor, because all of our ECL classes use Thor, and only the Roxy classes actually use Roxy, but they all teach ECL. So we've renamed our introduction classes to Part 1 and Part 2. Our advanced classes are now Advanced ECL Part 1 and Part 2, and our Roxy classes are now named as Roxy ECL Part 1 and Part 2, because once again, they are specifically about the ECL kind of code that you write on your Roxy queries. And one other thing that I would like to hear from everybody is whether or not you have already taken all the ECL courses that you would like to. And that's a pretty simple question. We'll get to those answers later. Because the answer to the first one is we actually deliver our training now 4 different ways. We have live instructor-led on-site courses. We do live instructor-led remote courses using Link. Nowadays, that's also known as Skype for Business. We have pre-recorded self-paced online courses that are available 24/7 anywhere in the world to anybody. You can do it nights and weekends if you want. And we even have a couple of our courses, our first 2 introduction courses, are now available as mobile apps. These are the same as the online pre-recorded courses, but they're available on your phone if you want to take them on your phone. So we've got 4 course delivery methods. And to go into detail about this, the on-site courses, we have regularly scheduled on-site courses, instructor-led, in both Alpharetta, Georgia, and Sutton, England, once every quarter. So the first month of every quarter in 2017, we're having courses in classes in Alpharetta. They will be 2 weeks, 8 class days. There will be the Introduction to ECL, the parts 1 and 2 will be the first week, and the Advanced ECL parts 1 and 2 will be the second week. Now the Sutton classes, we're doing a little bit differently, where we're doing what we call a compressed course. Each of our ECL courses is a 2-day course, but we are compressing 12 actual class days into 10 business days. So we're compressing the classes in Sutton into a full 2 weeks of 10 days, both the introductions, both the advanced ECLs, and the Roxy classes. Okay? So the on-site courses are regularly scheduled in both Alpharetta and Sutton, and in addition to that, you can schedule, if you've got a minimum of 6 students, we can schedule ECL courses on-site anywhere in the world. The only cost will be the instructor travel for anybody that's in Relics group, any academics or external partners of ours. Talk to me about that, as to whether we can do discounts. And external folks, the prices of the courses are actually listed on the website. So we can negotiate for any of these courses where it's going to be, which courses we're going to be teaching your people, and the time frame exactly when it's going to be. Our remote training courses are also regularly scheduled, just like the on-site. The 3rd month of each quarter, we're doing a full 12 class days of remote training courses, both introductions, both advanced, and both Roxy courses. All 6 of those courses in 12 class days, presented through Skype for Business and taught remotely. And you can sign up right here at this link to get to all those classes that are pre-scheduled. And of course, we can also schedule for you remote courses. Instead of having an instructor travel to your place for an on-site, we could also do a remote course. We have a 4-student minimum for remote courses, and of course, we can work with you anywhere in the world. We have had courses where we were teaching students in India, and our instructor simply adjusted his time to better fit with the time zone of the students. So our remote courses, once again, just like the on-site courses, there's no cost for anything within the Relics group, and the courses taught and the time frames are negotiable. So we can just talk about when it's convenient for both of us. Our online courses, who thought we only had ECL courses? We've also got our HPCC for managers, our HPC systems administration courses that are free to everybody in the world, just like the first 2 introduction to ECL courses that are free to everybody in the world. Our online courses also move on to the Advanced ECL Parts 1 and 2, Roxy ECL Parts 1 and 2. We also have an applied ECL. It's all about code generation, macros and function macros and template language, things like that. And we also have online SALT classes for SALT and Introduction to SALT and the Advanced SALT. We have not yet done an online course for KEL. I know that there's a lot of interest in KEL courses. I do have a KEL course that is almost ready to release and start teaching, and we will start that probably in the next couple of months. Certainly sometime this year we'll be presenting it and getting it through its first test, and then more widely publicizing it and adding it into the mix, and we will put that available as much as possible also, along with all the rest of the online courses. So we've got all of these, and we've got discount codes for signing up for all of the courses that nominally have fees associated with them, and all you need to do is send a email to training@hpccsystems.com to get the discount codes if you need them. So the mobile app courses are freely available to everybody in the world, and it is only just the two completely free Introduction to ECL courses that are available on the mobile app. And if you've got an iPhone, use the Apple link. For an Android phone, you can use the Android link and just download it onto your phone and have fun with it. So, at this point, that's pretty much all the information about the courses that I have. And I think the person that asked where can I get hands-on learning options about the HPCC platform, I think I just answered that. At least I hope I did. So the quick poll here is, have you ever used the ECL loop function in your code? So this is where I'm going to actually start doing screen share here and dive into a little bit of code just to talk about something a little more interesting than where and when we teach this stuff. So what we have here, what we're looking at now, is the loop function. And as I am fond of saying in class, there's absolutely no such thing in ECL as a loop. And then some bright spark will come up and say, but what about the loop function? And my answer to that is the loop function doesn't loop. It's recursion. So we have here, as you can see, 5 different ways. That doesn't seem to be showing up. Okay, well, I'm trying to be, oh, there it goes. 5 different ways of accomplishing this loop, and I'm going to show you a couple of pieces of example code that demonstrates the kind of thing that they do. So I had a problem that was presented to me in an email from somebody. They had a set of strings, S1, S2, S3, and they need to concatenate them in every way possible that it was to concatenate them. In other words, put all those values into a single string in every order possible, which would be, of course, for S1, 2, and 3, you got S1, 2, 3, S1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1 are all the possible variations on that. How can we do that? And that is exactly what this little function does. It takes a set of strings as it comes in, and I get the count of the strings of how many elements there are in that set, and I create a record structure for my starting data set, which is going to be that set of strings. So that all I need to do is loop through my starting data set. Now the loop function, the first form of the loop function simply says how many times do I loop, and that's the third parameter here, and I'm going to loop one less time than there are elements to the set. So I'm going to get that count and loop one time, and I'm going to start my loop with the starting set of data set that I have here. And the loop body, the function that's actually going to do the work, is going to be called this joins function, which takes as a parameter a data set in my record structure format. And I'm calling that LDS, my left data set. And you'll notice that what I'm passing to that joins function is rows left, which is shorthand for saying whatever result set I'm working with. The first time, it's going to get the entire data set from my start data set, and rows left is going to also give me the results from the previous data set. So therefore, it's going to be recursing through and producing the result. So that what I'm doing here is I'm doing a join of my left data set with the start data set. In other words, what is coming in on the left, that's my rows left, and I'm going to join that against the start data set. And I'm looking for the left line in the right line, looking for the first instance at 0. In other words, that's what I'm considering a match. In other words, if I don't find the left line in the right line, that's going to be 0. It's not going to be finding that. And then it's going to call my transform function, passing it my left record and my right record. I'm doing an all join, which means I'm going to start with all the records in my starting data set on the right-hand side. And my transform function is simply going to concatenate these strings to the line, producing, when I pass it the S1 and S2 and S3, it's going to produce this result. Exactly as I showed you in the comment. And if I pass it the set of 0, 1, 2, and 3, then I get this result, which I believe is, yes, 24 results. Come on, you can show it. There it goes. So as you can see, you get all the possible combinations of those 4. That's one demonstration of what the loop function does. It recurses. And from a fairly recent forum post, I've got this little bit of code where the gentleman has a data set with strings that contain full names, and he's got a data set of surnames, last names, that he wants to exclude from that result. So he's got to be using the ends with function to get rid, to find the records where that string ends with the last name and eliminate that record. And we can do that for one name very easily by simply using the ends with. But how can you do that where you've got Siobhan and Smith and Jones that you want to exclude? You want to eliminate Smith and Jones and Siobhan and just end up with the 2 middles. And that's where the loop function is going to recurse. It's going to recurse through my set of people records. Here's my set of people records. And my exclusion count is how many surnames do I have? How many times do I need to do this exclusion so that I can call my filter rex function, passing it rows left, and that's going to be the data set that it gets in, and the string to include. And the counter keyword is going to give me which loop iteration am I on, and so my exclude surnames on the first iteration of this guy is going to be 1. So exclude name sub1 dot surname is going to give me Siobhan. So the result for my first iteration is going to filter my data set where there's where the record does not end with the name to exclude. And when we run this code, we very nicely get that. And so that loop is going to recur 3 times. The first time, the first loop, it will get rid of this record. And then the second loop, it will get rid of that record. And the third record, third loop iteration, it will get rid of that record and leave me just that single result that we just saw. So that is a deep dive into just a little bit of code to tantalize you into thinking about how can I possibly use the loop function in my code. And we've explored the loop function, and there we go. Now it's time for questions.
All right, Richard. So since we're just talking about the loop, we'll talk about the ECL loop question. Have you used the ECL loop function in your code? And so 43% have, but 56% have not. So hopefully this was a good tutorial for them. Have you taken all the ECL courses you'd like? Richard, it looks like you're going to be busy in the future because 35% said yes, but no said 64%. So a lot of people are still looking to take additional classes, which is good. And you definitely tricked our audience. Only 66%, or only 33% guessed correctly that there are 4 different ways to attend training, and 66% had guessed 3. So they were definitely close. All right. So to get to our questions, it looks like our first one is you mentioned calc classes. Do you intend to have ECL template language specific classes in the future?
As a matter of fact, we can go back to the future. Let me go back a couple of slides here. Where am I? That's where I want to be. And the applied ECL code generation class, that code generation class that's available online is specifically working with how to use macro and function macro and the ECL template language. So the Back to the Future answer is yes, we will in the future have it because we've already got it.
All right, Richard. And, well, we've answered the question, I think. Where can I get the hands-on learning options about HPCC systems? If anyone has any further questions on that, please feel free to submit them. Here's one additional question, Richard. Do I have to be a developer or have any prior experience to take these classes?
You do not. We have had people in class with multiple PhDs in computer science, and we have people in there that had never even handled a mouse before. And it comes down to what is it that you need to do with ECL. If what you want is an overview of what the system is all about, then I encourage any manager to take the HPCC for Managers course. That's pretty simple. Or if you want to get your hands a little bit dirty and get more of an introduction, then join our Introduction to ECL course. Part 1, absolutely. Part 2, if you're really having fun with the Part 1, because this stuff it's not. I don't want to say it's not that difficult. I just find it fun.
All right, Richard, thank you so much for joining us today. So we are all done with our Tech Talk for the day. If you've listened through everything and you've thought, hey, I've got something great that I'd like to offer to the community too, we really welcome you to submit a talk for an upcoming episode. If you have a success story or if you want to pitch a new use case, if you have a special application or even some ECL tips or sample code, we'd love to have you join us. Same thing if you have a suggestion for our roadmap. We welcome you to be one of our featured speakers. The information is right here. We will definitely have a blog up with all the information and answers to these questions, as well as links to the presentation up later on today. And you can look at our wiki for the Download Tech Talks to get more information. So we are all done today, but before we close, we'd like to do a special shout out to someone who's very special on our development team. Arjuna Chawla is celebrating a birthday today. So everyone, please wish him a happy birthday.
Happy birthday to you.
All right, thank you everyone. Have a great day.